5.14.2. The following data are given for a vibratory system with viscous damping, mass 2.5 kg, spring constant. Look at the unit, Newton per mm. What is the meaning of spring constant? Stiffness. It is given as Newton per millimeter. You have to convert it into Newton per meter. Therefore, into 1000. Okay. And the amplitude decreases to 0.25 of the initial value after 5 consecutive cycles. This sentence you have to read very carefully. Amplitude decreases to 0.25 times the initial value. Okay. So that is 25% of vibration only remains after 5 cycles. Clear? So after 5, let us say I am vibrating by 5 millimeter. After 5 cycles of vibration, you will vibrate only by, I'm sorry, not 5, 4 millimeter. Okay, if you are vibrating by 4 millimeter amplitude in the first cycle, after 5 cycles, you will vibrate by 1 millimeter, 25%. Okay. Determine the damping coefficient of the damper in the system. Here the question is, what is the value of C? Okay, damping coefficient. So given data, mass is 2.5 kg, spring stiffness is 3 Newton per millimeter, which is 3000 Newton per meter. Okay, so then one relationship is given to you indirectly. Sixth cycle of the sixth amplitude is 25% of first cycle. Okay, because after 5 cycle will come your sixth cycle. Therefore, x6, x means amplitude. Okay, so x6 is 25% of x1. It is very small. It is reduced by 75% and has become 25% of the first cycle. Okay. Natural circular frequency formula, root of s by m, these two values we have, find out omega n first. Okay, so s is 3000, mass is 2.5 kg, calculate 3000 by 2.5, which is 34.64 radians per second. Now you have to convert this to linear frequency. Let C equal to damping coefficient of the damper in Newton per meter per second. It is unknown. I am keeping it as unknown itself. Okay, x1 is the initial amplitude, x6 is the final amplitude after 5 consecutive cycles, 0.25 x1. Okay. So here this I already told you when I was talking to you about the derivation, logarithmic decrement. Whenever you say logarithmic decrement, it means the ratio of successive amplitudes are constant. So first cycle and second cycle, amplitude, ratio of amplitudes. Second and third, third and fourth, fourth and fifth, everything is constant. Same value you will have for all the successive cycle ratios, amplitude ratios. Okay. So what I can do this, so if I want to find out the ratio between the first and the sixth, I can multiply all these things. What will happen if I multiply? So what will happen? This x2 and x2 will get cancelled. Okay, x3 and x3 will get cancelled. 4 and 4 will get cancelled. 5 and 5 will get cancelled. So I can write this is equal to x1 by x6, correct? Very simple, straightforward. But I also know one more thing. What I know, all these things are equal. x1 by x2 is equal to x2 by x3, equal to x3 by x4, equal to x4 by x5, equal to x5 by x6. Everything is equal. Therefore, you can write this as also as x1 by x2 whole power 5 because I am multiplying it 5 times. Correct? All things are equal. If they are equal, you are multiplying them 5 times. You can write it as x1 by x2 whole power 5. So, if I want to find out x1 by x2, I can reverse this power 5 to the left side. So, x1 by x2 equal to x1 by x6 whole power 1 by 5. Correct? So, I know that x1 by x6 is 25%. This relationship is given in question. Correct? x1 is x1, x6 is 25% of x1. Correct? You can cancel these two. Eliminate it. Therefore, 1 by 0.25 whole power 1 by 5. 1 by 0.25 is 4. So, what is the fifth root of 4? That is your amplitude relationship. x1 by x2 equal to 1 by 0.25 the whole power 1 by 5. So, if you solve it, you will get 1.32. Okay, so what is that? Amplitude reduction factor x1 by x2. x1 is the first amplitude, x2 is the second amplitude. So it reduces by a value of 132%. And this 1.32 is same for all the successive cycles. So if you see 2 and 3, it will be 1.32. 3 and 4, it will be 1.32. 4 and 5, it will be 1.32. Okay, so that is constant. So we know that log base E x1 by x2 equal to a into 2 pi by omega n square minus a square. Okay. So bring that 1.32 and put it here. So x1 by x2 equal to 1.32. Bring it here. Log base E 1.32 equal to a into. So a is unknown value. Keep it as a itself. into 2 pi by square root of omega n I have already found out earlier. So 34.64 put it here minus a square. So out of this you solve for a. Okay, find out the value of a. So this particularly this log term you can take your calculator and check whether you are getting the, if you put log of 1.32 your answer will be wrong. You have to put ln of 1.32, ln. Search your calculator, see where it is. I don't know how many of you are having your calculator in the hand. So use the ln operator in the calculator and find out the value of 1.32 ln of 1.32 because log base e is ln, natural logarithm. Okay, so ln of 1.32, but in book it will be given like this only. When you are calculating how to do ln. Ln of 1.32 equal to a into 2 pi by square root of 34.64 square minus a square. So solve this, you can find out the value of left hand side. Left hand side is also known. So 0.2776 equal to a into 2 pi by, so 1200. If I square the 34.64, I get 1200 minus a square. So cross multiply, squaring on both sides, I am eliminating the square root. Okay, so I am mathematically manipulating everything and I am calculating the value of a. So all these things you have to do. Okay, so I don't think you need explanation for this. You can just solve for a from that relationship. So it comes around 1.53. What is a? C by 2m. Okay, I know that a equal to c by 2m. So 1.53 equal to c by 2 into 2.25. So the 2.5, therefore c equal to 1.53 into 2 into 2.5, that is 5. Okay, multiply that, you will get 7.65 Newton per meter per second. So this is the answer. What is the answer? What they have asked you to find out? Find out the damping coefficient. So hence damping coefficient equal to 7.65 Newton per meter per second. That's all. Okay, that's what is asked to find out. So this is your problem 23.10 in Kurmi textbook.